Today's lesson is all about combinations. In the last section, we talked about permutations, and permutations are all about ordering things, and so the order is important when we're talking about permutations. When we're talking about combinations, it's really important to remember that the order is not important. The order is not important. So, for instance, the sets A, B, and C and B, A, C are equivalent because they both contain the same three elements. So you would only count those one time. A really common example and a good way to think about combinations is a card game. So if you're dealt 5 cards, you can rearrange those 5 cards in any order that you want to. One hand would be only counted one time. The order that you arrange those cards is not important. For example, in how many different ways can 2 letters be chosen from the letters A, B, C, and D? So we're thinking about choosing 2 of these letters. Well, we can choose A, B, or we can choose A and C, or we could choose A and D, or we could choose B and C, or we could choose B and D, or we could choose C and D. Well, we wouldn't also list BA or DC because those would be considered the same combination. So 1, 2, 3, 4, 5, 6. There are 6 possible combinations. This one is short enough that we can just write a list and count them up, but we need a formula or we need a way to be able to do something similar if the numbers get larger. So we have a formula for that. The formula for combinations of n total elements taken r at a time looks like this. This is a combination of n choose r. And the formula is n factorial divided by n minus r factorial times r factorial. You can find this function in your calculator, and it's under math, probability, and then depending on what version of your calculator you have, it's either number 3 or 4, and it looks like this, NCR. Let's go back and look at that same example and see if we can figure it out using this formula. Well, this is a combination of 4 total letters. We want to choose 2 of them. And how many different ways can we arrange 2 letters? Well, we would take the total number factorial and divide by 4 minus 2 factorial times r factorial, which is 2 factorial in this case. So we've got 4 factorial. 4 minus 2 ends up being 2 factorial times 2 factorial. And if we expand this, we get 4 times 3 times 2 times 1. Oops. Divided by 2 times 1 times 2 times 1. Well, we can cancel common terms. We can cancel these. We can cancel this 2 with a 4 and turn that into a 2. And then we can see 2 times 3 is 6. So we've just verified the formula with this example. Let's take a look at a few more examples of combinations. How many ways are there to deal a hand of 5 cards from a standard deck of 52 cards? Well, this is a combination. Out of 52 total cards, choose 5. How many different possible hands of cards can we be dealt? Well, we can use our formula. This would be 52 factorial over 52 minus 5 factorial times 5 factorial. 52 minus 5 would be 47 factorial times 5 factorial. And at this point, you can pop all of that in your calculator because these are some really big numbers. And you should get 2,598,960. Example 11. For a certain experiment, 4 students are randomly selected from a class of 20. How many different groups of 4 students are possible? This is a combination. Out of 20 students, choose 4. So we can write 20 factorial over 20 minus 4, which is 16 factorial, times 4 factorial. And we can actually think about simplifying this before using our calculator. 20 factorial, well, we can cancel the 16 on down with the 16 in the denominator. So this is 20, 19, 18, 17. Again, the 16 on down will cancel with the 16 in the denominator. And then we still have 4 factorial in the denominator. We still have 4 times 3 times 2 times 1. And now at this point, this is a little more simplified to type into our calculator, and we should end up getting 4,845. Example 12. You are forming a 10-person committee from 9 women and 12 men. The committee must consist of 5 women and 5 men. How many different 10-member committees are possible? So there's a lot going on in this question. The best way to think about it is going back to that fundamental counting principle. And that fundamental counting principle says that if we have 2 separate events, in this case, the first event would be we want to choose 5 women. And the second event is we want to choose 5 men. Well, how many different ways are we able to choose 5 women? How many ways can we choose 5 women? Well, we can choose some combination out of the 9 total women, choose 5 of them. In how many ways can we choose 5 men? Well, again, this is some combination of the 12 possible men to choose from. We're going to choose 5 of them. And it's important to note that we're not using permutations here because the order is not important. It doesn't matter in what order those men or women are chosen. It's just a subset of the larger group. And so we're multiplying these together, again, because of that fundamental counting principle. There's 9 choose 5 ways to choose 5 women, and there's 12 choose 5 ways to choose 5 men. You can use your calculator to evaluate each one of those and multiply them together, and we should end up getting 99,792. Just to summarize, it's really important to think about the difference between permutations and combinations. Before you attempt any problem, you need to ask yourself this question. Is the order important? Is the order important? If it is important, if the arrangement matters, use a permutation. If the order is not important, if you're just thinking about taking a subset from a larger group, use a combination. And if the problem involves 2 or more separate events, then you also need to include that fundamental counting principle. One last thing I want to mention is that your whole lives, you've been calling this a combination lock. But now that we know about permutations and combinations, this shouldn't be called a combination lock because the order is actually important. This should be called a permutation lock if we're being mathematically accurate. That's it for our lesson today. Thanks for watching.